now I'm going to give you an introduction to double integration. So double integration allows you to work out the volume underneath a surface. So let's say you've got a surface, this is your surface, and you will be given a region to work with. So this is our region here, this is our region, and in the x direction we are integrating from A to B. We are integrating from A to B in the x direction, and then in the y direction we are integrating from C to D. From C to D. So the volume of this thing here is given by this. So in this video we are going to try and understand what's going on here. Okay, but before we do, I need to remind you of integration in single variable. So in single variable, let me give you a quick reminder. You're given a function like this, f of x, and we're trying to work out the area. So we would cut up into n number of strips. We would cut it up into n number of strips. So we would get the whole length, which is b minus a, and then cut up into n number of strips. In our case it's 4. 1, 2, 3, 4. So b minus a divided by 4 would give us delta x. That would then give us this width. That would then give us this width. So delta x is this width here. And for given x subscript 1, so we would scan through all our strips. For the first one, so let's just say this is x1 here, we would put it into the function, and then it would jump to the function. So this thing here represents the height. So you would get the height times the width. That would then give us the area of this rectangle, and then we would scan through all the rectangles. So for the second x, we would put it into the function, so it would give us the height, and then we would times it by the width again, and then we would sum up all the rectangles. So eventually, so the area is approximately this whole thing here. But then when you take the limit as n tends to infinity, meaning when you have millions of these strips, the strips become thinner and thinner and thinner, then it will become precisely equal to this thing here. And then using the fundamental theorem of calculus, which took us ages to understand, within the fundamental theorem of calculus there was this thing here, there was this thing here, there was the mean value theorem, there was this thing here. Inside the fundamental theorem of calculus, it allowed us to jump from here, from a summation to an integral. We've already done this, and I'm expecting you to know this. We've already done it. So by using the fundamental theorem of calculus, we can jump from summation to integral, and this delta x becomes dx. We've already done this. I'm expecting you to know this. So now let's jump to double integration. So with double integration, the volume is approximately, now the idea behind this is that we would get this whole length. We would get this whole length here, which is b minus a, and then cut up into m number of strips. In our case, it's 5 for the time being. It's 5. So this represents our delta x. So this length here is delta x. This length here is delta x. This length here is delta x, and so on. We would get d minus c. We would get this length here, d minus c, cut up into, in our case, 7 pieces. 7 pieces. So that represents delta y. So this is delta y here. This is delta y here. This is delta y here, and so on. So when you get delta x times delta y, that represents a small area. So let's just imagine this area here. It represents this area here, and it's an area. It's not a volume yet. So this here sometimes is written as delta a for an area. So for a small area, so this is for a small area. Later on, this thing here allows us to scan through all our areas here. It allows us to scan through all of them later on. But at the moment, I'm going to give you 2 versions of the explanation of this thing here. The first one, I'm just going to gloss over it to give you a rough understanding. In the next video, I will take it step by step to show you what's really truly happening inside here. but for the time being I'm going to give you the first easy version. So the first easy version is that this thing here represents the area, and when you put it into, so when you put your current location into the function, it will jump to the surface. So let's just say our current location's here. We put it into the function, it will jump to the surface. It will jump to the surface. So so this thing here is your height. This thing here is your area. That's this area here. And then when you multiply the two together, it will give you a volume, because this is your height, this is an area. So multiply the two together, it will give you a volume. So it will then give you this volume here. So you can think of this as, well, from here straight up. So this is like a box. So this whole thing here represents the volume of that box. And then you would scan through all the boxes. So jump to the surface, it will give you another box, and so on. And then here, jump to the surface, it will give you another box. So you would sum up all the volumes, and then eventually, well, let me show you this. Hang on. So you cut up that you would sum up all the boxes. This is just an approximation. So later on we can take the limit as m and n tends to infinity. Well, as you head towards infinity, as you increase the number of strips or boxes, then it becomes more and more and more accurate. So eventually it will be the true volume. So that's the idea behind it. Hang on. So the idea here is to imagine this as being an area, and then for this thing here, it's just a way for us to scan through the whole system, which I will explain more in the next video. It allows you to scan through all our areas here, and then this thing here, well, for your current location, because later on it's going to be here, 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 here. Let's just say we're currently here. You put into the function, it will jump to the surface. So this is in effect our height here, and then you would times it by the area. Well, if you have an area and then you times the height, it will give you the volume of one box. And then later on you sum up all the boxes, and then it will eventually lead you to the volume. So that's just a rough explanation. In the next video I will take it step by step and really explain what's really going on in here. Okay.